honour to pass over to Professor Valentin R. Troll.
Thank you very much. Thank you, Robert, for the nice introduction. And yes, as Robert said, the schedule was initially planned to be a little different, but we make it work, of course. And today I'd like to talk a little bit about Humboldt's travels and his visit to Tenerife. And I added a little extra at the end of the talk, and that is one of the people who was intensely inspired by Humboldt was actually Charles Darwin. So I will add a few words about Darwin's travels and what he copied from Mr. Humboldt at the time, what he learned from him, and how he took it actually a little further than Humboldt in the studies of natural phenomena. So Humboldt's visit to Tenerife, well, many of us tried to go up to Teide and the national park yesterday, but because of weather, it didn't work. So I'm going to show you some images today of what, sadly, you have missed. So, first of all, Tenerife, it was long known by sailors as a reference point. It was a navigational landmark, and here is a drawing from the 1680s. It's a Dutch drawing, and it shows Teide. And of course, it's a little exaggerated, but it makes the point that this was a landmark, a widely visible landmark. And it stands above the Sea of Clouds. The Sea of Clouds is a term that Humboldt coined. It's this level of clouds up to about maximum 2,000 meters usually. So, and you see Teide peeking through above the clouds, and that makes Teide visible for a long distance. Sailors couldn't necessarily see the lower part of the island, but they could see the peak. And that was a really important reference point for them. So it sticks out above the clouds, and this makes it really, really important. For a long time also, Teide, the peak of Teide was considered the highest point on our globe. Of course, that's not true. We know that now, but it was believed. And it's still the tallest peak of Spain, by the way. So there is something to this. And people actually believed if you were to climb up to the peak of Teide, you would burn. You would be so close to the sun, you would die. So its exact height was, however, not known. And in addition, at Humboldt's early years, in his formative years, there was this news coming about a big volcanic eruption, a bit like the La Palma eruption from last year, I picture it. So there was these reports about eruptions in 1704-5, in 1706, and in 1798, just the year before Humboldt came to the island. So he was really keen to see the eruptive rocks at the time. So, Alexander von Humboldt, well, he was from northern Germany, from Prussia, and when he heard about these phenomena, these eruptions, then he got all excited. So here's a number of contributions that go back to him and to Tenerife. First of all, he actually established the height of Teide and used trigonometry for that. And then he solved the question of how basaltic rocks form. There was a big dispute. I'll talk a little bit more about this later. And he then also made a very accurate description of how plant life changes with altitude, which is a fundamental feature when you think about agricultural exploitation of the island. So, but let's start at the beginning. He was born 14th September 1769 in Berlin, and the Duke of Brunswick, he was his godfather. So he came from a quite well-off background. He was brought up in Tegel, that's the family estate, and I have a little image, a little drawing of the family estate here. His father, Alexander von Humboldt, he was a soldier in the Prussian army, an officer, and his mother, she was originally from French Protestant family, but they were coming in large numbers to Prussia at the time. So he had mixed religion in the family, which was always a bit difficult for him, I understand. So in any case, he was brought up by Mr. Kund, which was a private tutor, so he didn't go to any public school. He had a very special private education. So his father, he died relatively early, 1779, and a little later, a few years later, Alexander von Humboldt enrolled at the University of Frankfurt, And this was together with his brother, Wilhelm von Humboldt. And he later became a politician in Prussia. So he begins studies for civil servant career, but it didn't go particularly well. He found that rather dull, and he gave up on that, which caused a break with his mother, which was apparently never fully repaired. So he then moved on to study in Göttingen, 1789 to 1790. At that time, he took a trip along the Rhine River together with Georg Forster, who was actually with James Cook on one of the world tours at the time. And so he must have had many conversations about traveling the world with his friend during that trip. And it's believed that this was very inspirational for him. So he then went to Hamburg. He studied there for a short while. He then traveled to the Netherlands, to France, and to England. In London, he actually met the president of the Royal Society, Joseph Banks, and there he was shown the collections of South Sea specimens. And that was another element of inspiration for him. So then he entered Prussian employment, Prussian state employment, and he was a mining engineer, and he got trained in Freiburg, Saxony. That's one of the old mining academies in Prussia. And there he got under the influence of a very eminent professor, Professor Gottlob Werner. And Gottlob Werner was a Neptunist, and that means that Werner believed that basalt, which we now know that it forms by eruption of lava from volcano, Werner believed this actually forms from precipitation out of ocean water. So basalt was a sediment in Werner's view. And this was the big Wernerian concept, which led to this dispute between the Neptunists and Plutonists, those that believed magma forms at depth and those that believe igneous or magmatic rocks form from precipitation. So when Humboldt concluded his studies, he was firmly of the opinion that basalt is a sediment, and he will come to change his mind during his travels later on. So he then started work, and he was sent to several places in the Prussian Empire at the time, and he was looking at gold production, and he was very good at his job. He was very good with rocks and minerals and things like that. He actually managed within 1 year to increase the gold production of one of his mines by factor 8. So he had a good sense, a good feel for rocks and minerals. And he started to publish at that time. He publishes on mineralogical observations on basalts from his Rhine trip. And as you might know, there's a little volcanic province in between the area between France, Germany, and Belgium. And it's the Lacher volcanic province. And it's still active, actually. And there he describes some of these rocks. So he travels to Austria, to Switzerland, and he publishes on cave botany at the time as well. So these are some of his early works. Then he gets very interested in exchanging his ideas, and he meets some of the important literary people of the time, Goethe and Schiller in Jena, and he exchanges information with them. Goethe himself being a mineral collector, so they had some common ground there. And then during that time, he actually goes on to have a second trip to Switzerland. So the mountains were something that fascinated him. And he realizes that altitude causes major changes to a lot of things, to the way humans respond, but also to the plant life, to the animal life. And this is something that he will explore further on Tenerife and later in the Andes, of course. So in 1796, his mother dies, and that gives Humboldt a lot of freedom. Suddenly, he has the freedom and the family wealth to do something different. And he, within weeks, quits his job as a mining engineer for the Prussian state, and he starts to plan trips to explore the world. So he prepares this great trip, And this is in support, or with support of the Spanish crown. So he sets off eventually here from Spain, going to South America. And there he explores the northern part of South America, the Andes, and then he goes up to Mexico, to Cuba, and he visits the United States, and eventually he comes back here. And then on the way, he passes Tenerife. And he spent 1 week on Tenerife, and this week was quite phenomenal to our understanding of the geology and botany of the Canary Islands. So he departs in June 1799 from Spain, and he has this 1 week on Tenerife. And he made the most of it, literally the most of it. He visits Teide, he hikes up to Teide with support of some local guide, of course, and they had a donkey and some supplies. And in his diaries, he complains that the guide was very lazy and that he didn't walk fast enough, and he was very keen. And so he also visits La Laguna and Anaga, the old forest in the north, east of Tenerife, and he explores the Orotava Valley. And he does note all his observations down. So yesterday, for those who were on the same trip as myself, we were in the Orotava Valley instead of going up to Teide. And this is from Humboldt's viewpoint. Unfortunately, there was clouds yesterday and we couldn't see the volcano, but that's how it looks. This is an old postcard from the 1950s. This is Orotava, and here we have Teide in all its magnificence, towering above the Orotava Valley. So, and we still today consider the Canary Islands as a volcanic experience, and Humboldt was really thrilled by all the observations back then. So, en route to America, Humboldt is on Tenerife. He visits all these places, and he makes these important observations. So, he also visits several people living here. He's invited. He has a busy social calendar. He's invited to several of the noble families in Orotava, and he dines with these and exchanges information. However, he plans to go to San Juan de las Ramblas, but he has to cancel that trip due to time constraints. So even Humboldt had some things that didn't work out perfectly. It's not just us. So, but one of his major achievements was he sets out to work out the height of Teide. Now, he was not the first one. There were several attempts beforehand, but Humboldt was the first one to confirm someone else's estimate. And suddenly there was 2 estimates that were almost identical, and that made a huge difference. So here we have the various estimates, and they go back to 1341, and they go all the way to the 1950s. And here we have all sorts of different units that have been used, and some of the estimates are quite mind-blowing. 27 miles, although I'm not entirely sure what type of mile that was used. And eventually Humboldt comes and he determines via trigonometry that Teide is 3,713 meters tall. The official height of Teide is 3,718, but it was revised only 2 or 3 years ago down to 3,715. So Humboldt was incredibly close. And he confirmed a previous estimate by a French researcher, Bourdin, and this means that there was now a good overlap. There was an independent test, and Humboldt confirmed this, and that was then widely accepted as the height of Teide. It's believed that apparently he said, in consequence to that, because he got all the glory and fame for this estimate, but he knew it was somebody else. So he said, there are 3 stages of scientific discovery. First, people deny it's true. Then they deny it's important. And finally, they credit the wrong person. So he was aware that it wasn't his achievement as such, but of course, it was good for his career that people widely thought of him as the person who solved the puzzle. So this is an image from 1798, and from the eruption there, and Humboldt was really intrigued by this, so he looked at various rock units as well on the way, and he got the first inkling that basalt forms from volcanoes rather than from ocean floor precipitation. And later in the Andes, he actually saw volcanic eruptions, and that really sealed it for him. So Tenerife was setting the scene for him to change his mind, and this was fundamental because subsequent researchers like Lyell and Darwin, they built on that and eventually making sure that the world was aware that basaltic rocks from volcanoes. So this is what he would have seen up on Teide. This is the Caldera de las Cañadas, and this is the Teide mountain. And here we have the lavas negras, the medieval lavas that have come from the summit of Teide. And they form typical lava structures. And when he saw these, he really started to doubt the ocean floor precipitation concept. Nowadays, you can go up there with a cable car, but Humboldt went up there on foot. And when you go to the very peak, this is up here, then you would see the crater. The crater is unfortunately badly damaged. It's partly filled in because of mining that was happening there during the Spanish Civil War. People mined sulfur there, So here you see sulfur crystals from the Teide summit. Sulfur is used in gunpowder, and this was very important in those not so peaceful years. And therefore, unfortunately, the crater is a bit spoiled by human activity, but it is what it is. So another kind of important feature up there near Teide summit is the ice cave. And the local people knew about this because what happens is that there's a little cave up there near the summit, and because temperature are often very low, when there is precipitation, you actually get snow and ice, and water freezes in there. So you have this pile of ice in there. And local people would go and pick up ice and bring it down to Orotava. And then the rich people of Orotava could have ice creams. And Humboldt was inspecting this apparently, and he was quite fascinated. And this was important for him because he also realized that temperature changes. Later on, he would write down that temperature changes with altitude are very similar to temperature change with latitude. He realized if you go further north on the planet, it would be similar than going higher up. And well, I'm based in Sweden, and if you go to the north of Sweden, you certainly realize it gets very, very cold. And this is what Humboldt realized when he went up to Teide. So Humboldt struck also by the vegetation change, because looking up here at about 2,000 meters of altitude and 3,700 meters here, not only do you see the snow being well marked here at this level, and you see there's a very sparse vegetation only up there. And if you look towards Anaga, then you see this ridge shape and the sea of clouds. So Humboldt also observes the sea of clouds at that point, and he makes abundant notes about all these phenomena. And when you go up to Teide or coming down from it, you also realize at some point trees are coming in. The Canary pine forest sets in, and this is a Google Earth image. You can see there's a somewhat green rim here, the corona forestal, the crown of forest. And this is because of the Sea of Clouds. The Sea of Clouds brings a lot of moisture, and the pine trees, the Canary pine trees, have these extremely long needles. They catch the water from the clouds, the water condenses, drips down, and this is how they get their moisture. So he notes all these differences in vegetation, and then he links it to the Sea of Clouds, and he really kind of starts to make the first sense out of how vegetation, altitude, and precipitation work together. When he goes yet further down, on his way down from Teide, he realizes if you step out of the forest at some point, there's banana plantations that have been heavily used. And here's a few images. These are some older images from the 1950s, and this is from the present day. Near the coast, there's abundant plantations, and certainly the north of the island in Orotava is extremely fertile to the present day. And Humboldt, of course, realizes there is a systematic change, and he draws this sketch. So down here, he draws the palm trees and the banana plantations. Then he has various bushes and the laurisilva forest here, laurisilva. And then the pine forest, and eventually you get into this tundra-like area above the pine forest, and eventually to the peak of Teide that is snow-covered. So he realizes vegetation changes with altitude and therefore with temperature. So not only did he measure the height of Teide, he also realized that the different levels of altitude have completely different implications. So here's one of these sketches from Humboldt, and he marks down the different plant species that he observes on the way up. He marks the gradation of the botanical changes, and here we have the sea of clouds that he realizes. All of this was recognized in a week. I mean, it's deeply impressive from a scientific point of view. So then there is Humboldt's cones, and this is a very intriguing case. So in the Orotava Valley, there are several volcanic cones. The Orotava Valley formed from a large giant landslide, and after the landslide, new volcanic cones grew inside the Orotava Valley. And here's one of them. You can just about see it here. Here's another one of them. But the intriguing thing is that Humboldt describes 3 cones in the Orotava Valley. And apparently he's deeply touched by the beauty of this situation. Today we only see 1.5 cones. There's one, there's a little church tower on top. There's the second, and it's partly quarried away, and there's a hotel on top. The third is gone. Well, what happened? The local people quarried it, and it was quarried so that nothing is left. These volcanic particles of the cones, they're very useful for agriculture, and it's a special ingredients they put on the fields here, and it makes the fields especially fertile. And of course, they also use it as aggregate to put it into cement, to put into tarmac and things like that. So the third cone is unfortunately completely gone, and only really 1.5 of those cones are left. And here's Humboldt's viewpoint. There's a monument to Humboldt on Tenerife at his viewpoint. Here's the Orotava Valley in all its beauty. Here's Teide Volcano. And apparently, on his last day, he said, "I'm leaving almost with tears in my eyes. I would like to settle here." But he never came back to Tenerife, unfortunately. So, but the missing cone, well, if you think about Lanzarote, and we'll visit Lanzarote, and I'll also give a talk about volcanic resources later in the trip, and there I'll go into more detail. But here, volcanic particles are used to fertilize the fields. Because volcanic particles, that's the real secret, they have little vesicles, they have bubbles. And in those bubbles, moisture from the dew gets held back. And that means the plants will actually have more moisture than if they were just on regular rocky ground. So this is why one of the cones has gone missing. It helped the agriculture, but of course it's therefore a little hard for a geologist because, well, we don't see the evidence in its natural beauty. Now, this trickery with the volcanic particles, it actually led to an agricultural revolution. And in a way, Humboldt was starting with this whole concept. But later on, it was also applied to many of the other islands. And it led to these large fields like here on Lanzarote, where volcanic particles are artificially brought out onto the fields in order to increase fertility. And at the Vienna Congress 1816, after Napoleon was defeated, you can read the menus, and people drank wine from the Canary Islands at the time. It was the most exquisite wine you could possibly drink. So Humboldt then travels on to America. I'll say a few words about that. He leaves for Caracas, and in November of that year, he inspects the area around that. He then goes to Venezuela. He explores the Orinoco, almost gets lost there. He then goes to Cuba, 1801, and then Colombia, Ecuador, Peru, and then he has this famous encounter with this big volcano, Chimborazo. And he has a companion with him, a French gentleman, and Well, it was a bit of a love-hate relationship, I understand. At times they got on, at times not. But Humboldt was probably the more pushy character, and he pushed them forward, while the French gentleman was often inclined to say, oh, let's stay here, this is very comfortable here. But Humboldt said, no, we have to go up the Orinoco, and things like that. So this is a map of Humboldt's travel. I showed it a few minutes ago already, and he explores the northern part of South America and then Central America, the islands of the central part of America, and eventually he goes even to the United States before returning to Europe. So Chimborazo is a very tall volcano, and it's in Ecuador. And here you see Chimborazo, and again, here in this image you see that there's gradation and there's a snow-covered peak, and further down you have different vegetation. Chimborazo is over 6,200 meters above sea level, and many of you probably know 5,330 meters is the level after which humans cannot inhabit altitude anymore. You can go there for a short time, but you cannot live there. So it gets really, really tough at levels above 5,000 meters. And I went to the Andes a few years ago, and I went to this volcano in Chile where this level was defined, Aucanquilchan volcano it's called. Whew, I was really out of breath at 5,300 meters. So, and well, Mr. Humboldt, he was a tough cookie. He went up there, Chimborazo. He was keen to climb all the way to the peak. He didn't make it though. And he went to 5,878 meters, a lot higher than I ever got actually. And I really give him credit for this. But his physical condition and that of his French companion was letting them down at that point, and they turned back at 5,878 meters of altitude. But they had an expedition force with them made of local support, and here you see some of the local tribespeople helping them, and here is some of these drawings showing the different levels of vegetation changing with altitude. And here in the deserts of the Andes, well, you have intriguing creatures that Humboldt, of course, described, and intriguing plant life, and this gave him a rich source of new knowledge. So then Humboldt in America, he then cruises to Mexico, and he stays there for a while. He goes to the US, and he actually meets even the president there. He's invited for dinner with Thomas Jefferson, and he then starts to kind of put all this observation into diagrams, into drawings, into visualizations. And he was actually one of the first scientists who did cartoons and sketches to visualize his findings. And here is some of these sketches here. This is the vertical gradation of the botanical features. And here as well, you can see how things are changing. The botany changes up to snow-covered peaks. And these illustrations are something Humboldt is really famous for. He made a huge difference there. Prior to that, scientists didn't really do that. So here's another one of Humboldt's illustrations, and here you see volcanoes. He actually saw real volcanic eruptions in the Andes, and he had snow-covered peaks there. You see the vegetation changes all the way up to the snow-covered peaks, and this is on the Andes. So here he notes in minute detail all the little observations, all the little plants he sees, and the changes there. And eventually he compares the areas of his visits with each other. So here's Tenerife. He realizes Tenerife is not as tall as many people thought. Actually, the Andes are much, much taller. He also compares it with information from the Himalayas, and he realizes that, well, there is this kind of pattern, that there is vegetation changes leading up to snow-covered peaks, and that makes him realize that altitude and vegetation change, and actually latitude change, it's all interconnected. He was a big picture thinker, and he realized that this is a global phenomenon. So in addition, he then brought a sample of guano from his South America trip back to Europe. And of course, it's a bit of an awkward thing. it's bird excrement. And he had it analyzed chemically. And he realized that in addition to volcanic particles, guano is very good for the gardens. And this actually caused the first guano boom in Europe. And eventually, people were sending ships to various islands, like the Galapagos Islands, to actually dig guano and bring it back to use it as a natural fertilizer. Only in the 1910 to 20s did we manage to produce chemical fertilizer, which was then another chemical revolution that allowed agriculture to flourish. But until then, it was really natural bird excrement that was widely used. So Humboldt then lives in France for a long time. He is quite famous. He gives famous lectures, but at some point he returns to Berlin. It's not quite clear why. Some people say that he actually ran out of money. The family fortune was spent, some people argue, and he had to kind of seek employment again. So he was going back to his home area, and he was, of course, welcomed there, and he went back into Prussian state service. So he then produced a set of very famous lectures that he also published as books, the Cosmos Lectures. And he then had various other trips, a trip to Siberia and places like that. And one of the universities in Berlin is named in honor of him and his brother. And so he had a very comfortable life, and here's his study in Berlin. So this is how he was aging after his return to Berlin, and he was publishing effectively as a professor in the university. So he then eventually dies May 6 in 1859, and he's buried at the family seat in Berlin. So Humboldt's major accomplishments: he collected on the order of 60,000 plants and animal specimens, many of which were previously unknown. He recognized even ocean currents, the Humboldt current. He recognizes many plants, and he recognizes that they can be used partly as a remedy, for example. And he's the first to really get the concept of climate zones and climate models. And here is climate zones on a global map, and if you read the small print, it largely goes back to Humboldt's observations. So here is the map I just mentioned, and well, because of his travels all the way down to here, and because of his travels to Siberia, he was able to put these very dispersed observations together in a global theme. So, Humboldt's accomplishments, well, countless places and phenomena are named after him. Actually, I think Humboldt is the person who has given name to most place names on the globe. And he was a thinker of the broad picture, if you will, and that makes him still special to the present day. He was a massive influence on later scientists like Darwin and Muir, etc. And this is where I want to talk a little bit about Darwin in the next few minutes as well. So, but he also had some critical thoughts, and I should mention that he already mentioned 200 years ago that the deforestation is likely a bad thing, that monoculture will cause many problems, particularly in the third world and in Southern America, and his holistic view of life and humans and their interaction with the landscape. That is really what he left for us. So, Humboldt's legacy: he invented botanical geography. He recognized these interactions between geology, landscape geography, and the human world. And he pioneered data visualization, as I said. He used sketches and maps and graphs. And more species and places are named after Humboldt than any other human being on the planet.